rivet in a lap joint used to connect two plates of 12 mm thick in a power driven rivets. We have to calculate the value for a power driven rivets. So we know that by using Unwin's formula, nominal diameter phi is equal to 6.01 root t, where t is the thickness, 6.01 root 12, that is equal to 20.8, approximately 20 mm. Let we take. So gross diameter is going to be, let me take it as d, nominal diameter plus 1.5, that is 20 plus 1.5, 21.5 millimeters. For a power driven rivets, we know that shear stress is equal to 100 Newton per millimeter square. Normal stress sigma F is equal to 300 Newton per millimeter square. Shear strength of rivet in single shear, we will find out shear strength in single shear is equal to pi by 4 d square area into tau shear stress, that is equal to pi by 4 d square is 21.5 whole square into 100, that implies 36.305 kilonewtons. Same way we will calculate the shear strength in bearing, that is equal to dt into sigma normal stress. D is 21.5, 12 into 300, that is equal to 77.4 kilonewton. So the rivet value has to consider the minimum of these two, 1 and 2, 1 and 2 minimum, that is 36.305 kilonewtons. So here in our options, option D is correct. It is a direct question, only we have to substitute the values in the correct formula, but we have to know the formula exactly. So the question is, a section of 300 mm by 600 mm size has ultimate bending moment of mu, we can represent 115 kilonewton meter. Shear or shear force, shear is Tu is 95 kilonewtons, and torsional moment, shear is 95 kilonewtons, and the torsional moment is 45 kilonewton meter is acting. Find out the equivalent bending moment. So we have to find out equivalent bending moment, me. So we know the formula, me is equal to ultimate bending moment plus torsional moment into 1 plus d by b by 1.7. So by substituting these values in this equation 1, we will get the equivalent bending moment, that is 115 plus 45, 1 plus d by b, 600 by 300 divided by 1.7, that is equal to 194.41, approximately is equal to 195 kilonewton meter. So option A is correct. The question is, the consolidation test was done on a undisturbed clay sample and the results are as shown below. E1 and sigma 1, E2 and sigma 2. E is the void ratio. So what we have to find out, void ratio for a pressure of the pressure sigma 3 is given, and we have to find out E3. So here we know the compression index. Is going to be a relationship between void ratio and pressure. So E1 minus E2 log base 10 sigma 2 by sigma 1. that is equal to E1 is 1 minus 0.8 divided by log base 10 sigma 2 465 by 85, that is equal to 0.271. If we know the CC is going to be constant throughout, so CC is equal to, for another third set of pressure, E1 minus E3 by log base 10 sigma 3 by sigma 1. Sigma 3 we know, E3 we have to find out. So by substituting these values, 0.271 is equal to E1 is 1 minus E3 divided by log base 10 sigma 3 600 that was given in the question, and sigma 1 is 85 from the above data. So by using this equation we can calculate E3, that is 0.77 we will get, and option A is correct. Here the question is, the descending grade of valley curve is 1 in 20 and meeting an ascending grade of 1 in 30. Design the length of the curve to fulfill the comfort condition. We have to find out the length of the curve, valley curve, for a design speed of 70 km/h is given, and acceleration is given as c is 0.6 meter per cubic second. So L is equal to, for a valley curve, 2 into n v cube divided by c whole power 1 by 2, where v is in meters per second. So n is equal to minus 1 by 20 minus 1 by 30, that is equal to minus 0.083. V is equal to 70 km/h, that is 19.4 meters per second. By substituting these values in the above equation, 2 into 0.083 into 19.4 cube divided by c is 0.6 whole power 1 by 2, that is 63.78 meters, approximately equal to 64 meters. 64 meters, option B is correct. As it is a simple question, we have to find out the error of reading of a level staff if the observed reading is 3.79 meters and at the point of sighted the staff reading is 15 centimeters off the vertical through the bottom. So if you see the diagram, the reading that we have observed is 3.79, that is diagonal, and it is 15 centimeters, that is 0.51 meters off from the vertical through the bottom. So what we have to find out? Actual value, that is diagonal square is equal to this side square, this side square. So that we will get it as 3.79 square minus 0.15 square, that is equal to 3.787. This is the actual reading. So the question has to be, find the actual reading. It is not error. Error is going to be the difference in these two readings divided by the actual reading. So the actual reading is going to be 3.787 meters. So option B is correct.